Hello, good afternoon, everyone. My name is Marisol Sumampong, and I am tasked to report on the Theorem 5.3 together with Ma'am Alviola. So my part of the report will be the second part, or part 2 of the proof, and the first part of the proof will be reported by Ma'am Alviola. So Theorem 5.3 states, or the order of permutation states that the order of permutation of a finite set written in a disjoint cycle form is the least common multiple of the lengths of the cycles. So the first part of the proof, as I have mentioned a while ago, will be reported by Ma'am Alviola, and the next part will be mine. But first, I would like to give a quick review on the first part of the proof before I proceed to mine. So first and foremost, let us remember that the order of a cycle is in fact the length of the cycle. So suppose we have alpha and beta are disjoint cycles of lengths m and n. It means that cycle alpha, the order of cycle alpha is equal to the length m, and the order of cycle beta is equal to the length n. So let us let k be equal to the least common multiples of the lengths m and n. So both alpha raised to k and beta raised to k are identity. So since alpha and beta commute, we can then write alpha beta raised to k. So if we are going to raise k to alpha beta, this allows us to write alpha raised to k times beta raised to k. So alpha raised to k is equal to the identity element, and beta raised to k is also equal to the identity element. So multiplying two identity elements will be equal to identity element. So raising k to alpha beta becomes identity, but it is not necessarily but we cannot necessarily say that k is the order of alpha beta. So that is why we need to show that k is equal to the order of alpha beta, or suppose t is order of alpha beta. So then we can write alpha beta raised to t equals alpha t beta t. So if we're going to raise t to alpha beta, we get the identity element. So we can also write alpha t beta t as alpha t equals beta t by taking beta to the right side. Now these two cycles, alpha t is equal to beta raised to negative t. Now these two cycles are said to be equal, which implies that alpha is equal to beta, which means that we can say that they have a common entries. But then it is given that alpha and beta are disjoint cycles. So meaning they don't share, or they don't have a common entry. So how is this possible? So it is only possible if alpha and beta are identity. So for example, for the operation of multiplication, the identity element is 1. So if we are going to raise 1 raised to 1 is equal to 1. That is also equal to, if we're going to raise 1 to negative 1, that would give us the same answer, which is 1. So it is only possible if alpha and beta are identity. So it follows then that both m and n divides t. So this shows that k is equal to t, since k is the least common multiple of the lengths m and n. So since k is the least common multiple, then it goes to show that it is equal to t, or it divides t as well. So therefore, the order of a permutation of a finite set written in disjoint cycle form is the least common multiple of the lengths of the cycles. So end of proof. So that's it for my report. Thank you, and may God bless you all.